let's have a look at 2014 question 10. Lugworms live on the seashore in dark, moist burrows under the sand. The graph below shows the average number of lugworms at different distances from the seawater at low tide. Then you get a graph that's got distance on the bottom in metres and average number of lugworms per metre squared up the left from 0 up to 35. And the question is, describe the relationship between the distance from the seawater at low tide and the average number of lugworms per metre. There's 2 marks for it, so you've got to tell them 2 things. And the first thing they're looking for is, as the distance increases, the number of population of lugworms increases up to 12 metres. So as you go along, it increases until you get to 12 metres on the graph. After 12 metres, the number of lugworms flattens out. So you've got to tell them 2 things. It increases until you get to 12 metres, and then after 12 metres it flattens out, and you've got to mention the 12 metres. If you don't get the 12 metres, and you say it increases and flattens out, you're only going to get 1 point. That's how you do that one. Next one. Calculate how many times greater the average number of lugworms at 11 metres is compared to 7 metres from the seawater at low tide. So at 11 metres, you're looking at 27, and at 7 metres, we're looking at 9. So at 7 metres there's 9, at 27 metres, no, at 11 metres there's 27. Divide 27 by 9, you get 3. That's just a wee mathematical one. It's not even really about lugworms, it's just getting some data from the graph and doing a wee sum. So 27, 9, divide 27 by 9, you get 3. That's that easy. Got to scroll up to the next page. Right, okay, so Dover sole and Rex sole are different species of flatfish and are predators of lugworms. So that just means they both want to eat lugworms. Curlews, which are a species of wading bird, also feed on lugworms, so they're all trying to eat the lugworms. There's a bit of competition going on there. Complete the table below by placing a tick in the correct box to show the type of competition that would occur between the different predators. So in the table you've got Rex, sole and curlew. Well, those are different species, so that is interspecific. That's competition between members of a different species. Curlew and curlew. Well, curlews are the same species, so that's intraspecific, competition between members of the same species. And finally, Rex sole and Dover sole. Well, they're both soles, but they're different species of sole. It's kind of fish. So because they're different species, that's interspecific. If you put an extra tick in there, it negates when it means cancels out one of your right ticks. So don't put in extra ticks. Each row should only get 1 tick. If you put in 2, you're not going to get any marks for it. So pick one, tick that one. Finally, a curlew gains on average 165 kilojoules of energy daily by feeding on lugworms. Select from the following list the value of the energy which is used for growth each day by the curlew. 1 mark. So there's a bit of biology and a tiny bit of arithmetic at this one. Remember when we had the food chains and we said that 90% of the energy gets lost at each step? Well, that means that 10% gets passed along to the next bit to make bits of the animal's body. So it gains 165 kilojoules per day, only actually gets a tenth of that, so because 90% gets lost in heat, movement, undigested material. So all we're looking for here is a tenth of 165. So 165 divided by 10 is 16.5, and you take the 16.5 kilojoules box. And that's all there is to it, and there's really not a lot of biology in that one either. There's a wee bit about the energy getting lost, and then you just have to do a sum dividing by 10. And that was question 10, 2014. If you want to ask me something about it, go right ahead.